I'm going to explain today liquid drop model of nucleus. Before starting liquid drop model of nucleus, let us first see what do we mean by a nucleus. The centralmost part of an atom where most of its mass and whole of its positive charge is concentrated is known as nucleus. As we all know that the nucleus consists of nucleons, that is the neutrons and the protons. The neutrons are neutral particles having zero charge and the protons are positively charged particles. The nuclear force binds all the nucleons together inside the nucleus. The characteristics of nuclear force are: the nuclear force is attractive and very strong in nature. It is stronger than the gravitational force and the electrostatic force. Secondly, the nuclear force is charge independent. That means it does not depend on the charge of the nucleon. The force acting between neutron-neutron, neutron-proton and proton-proton is same. The nuclear force is short-ranged in nature. It means that it is applicable only inside the nucleus when the range is short. It is saturated in nature. It simply means that all the neighboring nucleons exert nuclear force on the nucleons. Before starting liquid drop model, let us see the binding energy. The energy required to remove any nucleon from the nucleus is known as its binding energy, and it is equal to the work done to remove the nucleon from the nucleus. Let's start our topic, liquid drop model of nucleus. In order to explain the various properties of liquid, scientist Niels Bohr proposed this model, and in this model a nucleus is assumed similar to a liquid drop. The model is based on the following postulates. The first one is the nuclear density is very high. Secondly, the nuclear force are short-ranged in nature and they bind the nucleons together. There are some of the similarities between nucleus and the drop of liquid. The similarities are: the first similarity is that the shape of the liquid drop and the nucleus is spherical. The drop of liquid is spherical due to the surface tension, whereas the nucleus is spherical due to the nuclear forces. Secondly, the density of nucleus and the liquid drop does not depend on the volume. Thirdly, the process of evaporation inside the liquid drop is similar to alpha particle decay in nucleus. As we all know that in evaporation, since the molecules inside the liquid drop are always at constant random motion, there will be mutual collisions between the molecules, as a result of which energy of some molecules increases such that they escape from the liquid surface. This phenomena is known as evaporation of liquid. Similar to that, in alpha particle decay, since all the nucleons are undergoing constant random motion, as a result of which energy of some of the nucleons, a pair of neutrons, two neutrons and two protons, that means an alpha particle increases such that it escapes from the nuclear surface. Lastly, the similarity between the liquid drop and the nucleus is that the process of condensation inside the liquid drop is analogous to compound nucleus formation. The liquid drop model have various applications. The main application of liquid drop model is it was used to explain the nuclear fission process, and secondly, it is used to derive semi-empirical mass formula.